Still people are joining, I see. Okay. So, all right. And I switched off my video to limit my bandwidth. There could be a hiccup. I hope not too often, but my internet is not that good at the location that I am at the moment. So sorry for that, but I think we'll manage. But let me know, Kate, if it doesn't work. Then I pause a little until everything
Will do.
is functioning properly again. So hello, everybody. Nice to meet you. My name is Pieter Rambags. I am located in the Netherlands, and I joined ABW a couple months ago, primarily actually by teaching some of the stuff that has to do with my the business that I'm in and the career I've been involved in. A little bit about myself. I am the founder and owner of a company called Nippur in the Netherlands. We have two offices, one in the south, one in the east, and we help large companies with turning data into information. And our payload is taking data to heart because we think data is very valuable, very, very important. And you can do wonderful stuff with data, but also it means we want to make sure that people do the right things with data. So it means also make the world a little bit better. And that's maybe one of the reasons why I joined ABW. What we primarily do is we help customers build large data platforms. That's what I'm going to talk about today a little bit. And also we help them build reports and analytics and do execute some data science assignments. So also making some predictions and sometimes even some prescriptive solutions for clients. I myself have a background in information management for 30 years now. I studied at Tilburg University. I graduated there in '89, and ever since I was active in business intelligence. And throughout my career, apart from being a developer initially, a software developer, working with reporting tools, I later became project lead, program manager, and business developer. And that allowed me also to start my company that today is like 25 people in size. This is my agenda for today. Kate and Parvati were looking for somebody who could elaborate on information management more in general. And that's what I'm going to try to do, because part of the things we do as a company is we help businesses become more data driven. So this lecture is more about high over information management, what it means to an organization and how you should organize certain things, and also how to implement certain best practices. So it's not technical, it's not very detailed in that sense. It touches high over certain topics. And if you want, apart from this session, I'm always open to discuss. If you want to elaborate on one or more of these topics later on, feel free to contact me. You can find my contact details in Slack, and Kate and Parvati know where to find me. The topics I want to address is first a little bit of a definition, of course. Here's still a slide about myself, but I will skip that. I introduced myself shortly already. I want to talk about data architecture, the data architectures that are out now, that we see that are being implemented in the world, and how they affect things like user types that you can distinguish in organizations, but also something that I find very important is the information and data delivery paradigm, which speeds up the process of defining retrieving good insights from data. But I'll talk about that later.
Sorry, the presentation is a bit small. Can you focus on each slide one by one, please?
You'll need to just zoom in from Zoom.
Yeah.
So it's because of the settings. So if you use the Zoom, on Zoom, you can zoom into the slide yourself.
Yeah, but when you zoom in, the quality is getting not okay. It's not readable. That's why.
Let's see what happens, because this is only placeholders. I click on them and then I zoom in, and then I will
Okay.
open the presentation. So the slides will then increase in size. Yeah. So these are just placeholders. See them as bullets. So
Okay.
when you can read the titles like data architecture, user types, that's okay. But
Okay.
let's see, because otherwise I can maybe change. Okay. Then they asked me also to elaborate a little bit on data quality and what you can do to enhance it. So bad data is bad for business. And I finalized with data privacy protection, which is also a hot topic. And I want to share some thoughts with you as well there. Like this, if I zoom in, is this okay?
Yeah.
Yeah,
It's
okay.
better.
Well,
It's
this
better.
this is how it's supposed to work. Okay, so that's good. Okay.
Yeah.
Now this is just a simple word cloud, but all the words that are there are part of my day-to-day job. And wherever I go, I always touch on one or more of these words that are applicable when you want to make a company more data-driven. So like I said, becoming more data-driven is a monster with many heads, and each head needs attention if you want to tackle it. And today we only touch on like 4 or 5 of them, but there are many more. We can elaborate offline if required. The thing is that over the years, of course, data has become more and more important for organizations. When I came on the market, I found out that companies were more concerned with processes. And being a data consultant, I was always surprised, because you have these processes, and part of the role of these processes is that you collect data, and that you store data, and that you use data to benefit your company. So that's also, I think, why in the 60s, 70s, and in the 80s, when I started studying, information management became more and more important, because companies need strategies that think about data governance, collaboration, security, and analytics. How you can overcome certain challenges that are involved with these topics, and I will touch on some of them, and how you then really can harness the full potential of the data. Well, this is about me. I will not go into. Oh, by the way, you can find my details right up if you want to, so you can always reach me if you have questions you want to ask me. Let me dive into data architectures first, because this is one of the pillars that's quite prominent in all cases when companies want to become more data driven. One of the questions they always ask is, what do I need to do in order to retrieve the data and process it in such a way that we can really use it? And some time ago, that was rather easy, because there was no compute, there was hardly any memory, there was hardly any storage. So all the software we used was very limited in what you could do. You saw tools that encompassed all these features that you need, like getting the data in, doing some transformation calculation, and then immediately present the data. Well, today that's not working anymore. With growth in data, in volume, in complexity, and luckily also the enormous growth in compute capability, and the cost reduction when it comes to storing your data, large quantities of data. Today, we can do much more. However, that requires much more complex data architectures, unfortunately. And these data architectures are also evolving. So there is, on the market, people are looking around and seeing, what do I need for my company? And I will touch on some of the more actual architectures that are being implemented today as we speak, and hopefully I can explain also how it works and what it means. So if people talk to you about them, that you understand what's going on. Now this is more high over what's happening. This is quite generic, what needs to be done if you want to really set up a good data platform. In gray on the left-hand side, you have your data input, your source data, if you like. And traditionally, that was only data that resided in certain organizations. But nowadays, of course, we retrieve more and more data from outside the company. We even buy software. We make data stream from all sorts of environments. Sensors have become more and more important. There are billions of sensors out there, and that's growing fastly. And all this data companies want to connect to collect that data and store it. So then automatically you come to the second layer, what's here called the data storage layer. And there we do two things. First of all, we want to build up history. So if you collect data, certain data is transactional data. That is what it is. You can't change it anymore. But there's also a category of data that can modify. And if that happens, you still want to keep a record of the situation before. I give you an example. If you have a customer and the customer moves, buys a new home and goes to live somewhere else, you might want to have the old location where he or she used to live, and you might want to have and you have now the new location. This makes it also possible to compare certain occurrences. To use your data to examine what the difference is in buying behavior or in medical behavior, living in location A or location B. So we have the tendency as consultants not to throw away anything at all anymore. So when we build such a platform, we just try to keep everything. And the good news is storage has become cheaper and cheaper and cheaper. So we don't have to bother anymore. Another thing that you want to do in that layer is integrate your data. Because having data come in from very, very many different source systems and environments, hopefully a certain part of that data is similar. So I give you an example, if you're a company and you work with customers and you have various systems in which you store your customers and what the kind of transactions you do with your customers, then it can happen that you have the same customer twice or three times in different systems in your organization. Then you want to be able to combine all the relevant data you know of that particular customer in one view. And that's what we call integration. So we want to be able to store a customer once, but from whatever system the data is coming, that we are always able to relate it to that particular customer. I'll give you one example. We have one client who has 7 source systems. They're selling assurances. That's what they do, their business model. And every time when they came up with a new product, they had to build a new system for some reason, because it was hard to implement the new product in the old system. And some customers were buying more of their products, more of their policies. So they had a problem, and data integration became an issue there. Now that's part of the thing you can also implement in a platform like this. So you build up history and you try to combine data. Then the blue bar is about information delivery. That's where you start preparing your data to become usable by the business. So people can really use the data to decide on, to derive insights from it. So on the left-hand side, we talk about data. On the right-hand side, we talk about information. You transform data to information so it becomes valuable, because you want to get value out of data. So what we do is we create different data sets that fit the need of the end users. And that can be marketing, can be sales, can be finance, but it can also be a combination of those. So in the green part, where we talk about data storage, there you find all the information of the organization, all information all the time. In the blue part, we take part of that information and prepare it and give it then to the business users that need it for their decision-making processes. And that doesn't necessarily have to be all the data. So it can be that a marketing department says, I only need certain information from the last 2 years of information that we have, and leave the rest out. Now we call those things data marts. So they are more focused data sets. They are, by the way, in terms of data modeling, they are modeled differently, because they are modeled in such a way that reporting tools like Power BI, ClickView, Tableau, what have you, there are hundreds out there on the market, that they can use these data sets and visualize the data quickly. And then in the red color, that's where the information consumption takes place. I'll have another slide in more detail, but that's where you find typically your reports, your dashboards, your data science models. And that's where the different types of end users that we distinguish use the information to make the decisions. Now, at the bottom of this everything, we strongly believe in an automation of this whole data processing flow, because it's a flow from left to right. It's like logistics, data logistics. What you do is you move data from left to right, from data to information. And large part of this can be automated nowadays. Please be aware of the fact that there's software out there in the market, not necessarily very cheap, but that can do a large part of the data processing. It generates data platforms, it generates data models to store your data. And the good news about that is that you then can reduce the risk of having people build solutions and program solutions. People leave your organization, consultants come and go, but even people that are employed, they come and go. And what you don't want is when you have a data platform and somebody built it and the person leaves, that you're lost, that you don't know what they did and that you don't dare to touch it. Nowadays, that we live in an era where we have very good software tools that can automate the process. So whoever is using that kind of technology, you don't have to worry, because if they leave, somebody else can take over and can continue generating the same code as was generated before. Okay, now, and then of course 98% of the solutions nowadays are being implemented in a cloud environment. I come from an era where we had servers standing under tables. I'm happy that we leave that behind, because that went wrong quite regularly. Now this is the same picture. I will not go into maybe too much detail, not to scare you off, but it gives some examples of what's really going on in there and how we call certain things. On the left-hand side, again, you see these sources, the Excel sheets, databases, CSV files, JSON files, sensors, what have you. It's incredible, but we can all connect to these sources and get the data out. In the green area, you see that we distinguish some layers, like a source data warehouse layer, a business data warehouse layer. A source data warehouse is where you put the history. The business data warehouse is where you do some additional data integration and you add some calculations. You prepare your data already, but still you do it on all the data all the time. And then if you move to the right, here you see these cubes, and these are the cubes that I mentioned before. We call data marts. That's where the data is prepared for being used. And here you see some data user types already. And on the right-hand side, you see some tools that are being used nowadays. I think you will recognize some of them, maybe most of them, because they are quite common today in terms of their usage. What I will do later on is I will focus on this slide on the topics information delivery and data delivery. There's something I want to share with you. And I will elaborate a little on the different user types that we distinguish in organizations and why we believe they are so important. Yeah, but before I go there, so this is what I will focus on in a moment. Let's look at the time. That's still okay. But before I do that, I would like to share a little bit more about architectures with you, about what's going on today. Because what I showed you now, this architecture, this is what we now typically would call a data warehouse. That's a quite common thing or an architecture that have been implemented over the last 30, 40 years and has worked for many organizations. But that's now coming to sort of an end in terms of that it is also quite limited, because we saw the rise of unstructured data like text, video, audio, pictures, and more and more organizations want to use them as well to do some analytics. And that's not typical data that doesn't really fit in a data warehouse, because a data warehouse is traditionally built on relational database management systems like SQL Server, Oracle, Sybase. And they also have an approach of centralizing the data to one environment. And because we see an enormous growth in data, today these environments no longer can cope. And that's also why we saw the rise of what's called Hadoop in the past, thanks to Google and Yahoo, where today there exist architectures where data is not centralized, but it's like when you store it, it's like distributed over hundreds of thousands of small computers. And that's what we started calling big data. But that requires also rethinking your architecture. I'll show it here. I have 3 slides. On the left-hand slide, you see again the data warehouse that we've been using for many, many years. In this case, in my picture, you just saw it from left to right. Here you see it from bottom to top. So in the bottom, you find the source data, and in the top, you see the usage, the reports. However, you may have heard, or maybe you already are knowledgeable and already work with it. We saw the rise of the data lake, or the data swamp, as some people call it, because people said you can throw in anything you want, or even unstructured data, and decide later what you want to do with it. And we also implement data lakes. However, a downside of a data lake is when you throw data in, the person that wants to use the data still needs to be very knowledgeable and very handy with all sorts of software tools to transform the raw data to valuable insights. And it was introduced as the holy grail, especially for data scientists, because now they no longer were frustrated by the IT guys that took so long to build a data warehouse. Having a data lake, they could easily jump in and do whatever they wanted. I don't think. I think there's always truth in the middle or so. So there was another evolution. It's on the right-hand side now. It's what they call the data lake house, or the data lake. But if you look at it, you can see it's a contraction of data warehouse and data lake, like lake house from warehouse. As where people now say, nay, there are some very good things when data warehousing was concerned. So let's combine the two. So yes, let's have a data lake. Yes, let's throw in everything we have. But still, when the data is structured, we can still build layers on top of the data lake, where we can do the things I just mentioned, like build up history, integrate data, prepare some data marts for usage. But also, yes, people that want to dive deeper or want to use the unstructured data, they can still dive in, go into the data lake and retrieve whatever they want. So this tries to combine the best of both worlds. And I don't know if you heard about it already, but it's quite booming now. In Holland, we have like something called the Big Data Expo every year. And on the Big Data Expo this year, a lot of talks were about the successful implementations of data lake houses. I hope this gives a little bit of an idea of what was going on. So the data lake came on the market, but as everything, it was new. We had to find out how valuable it was and what the pain was. Now, when we found out what the pain was, people came up with a better architecture, combining stuff. Okay. Let's first elaborate on user types now, when it comes to data consumption. For the ease of use, what we quite often see in organizations is 3 types of users: the data consumer, the data analyst, and the business data engineer. And the last one is a tricky one. It's rather new as well, but it's a kind of person that's needed to help speed up innovation. And I will elaborate on that in a second. But why is it good to distinguish different data user types? If you work for a business in an organization, you have to be able, you have to build custom solutions that fit the needs of these users. It's like being a vendor of a product. When you build a product, you want to know how your market, how your audience is organized, who they are. Because if you know who they are, you can better tailor your product to meet their needs. And when reporting is concerned, there's nothing different there. We have executives, or managers, if you like, and they usually might need high-level summarized reports that give them a broad overview. And they are like simple consumers. The specs I'll touch on later. But other users might need more flexibility. They might want to do more deep diving, and they might want to handle the data themselves without having to be an IT person or having to be very technical. If you distinguish these groups, it makes it easier for you to help them and provide them with the stuff they need, the reports they need, but also the technology they need to use these reports. And that's what I would like to explain to you. So first we have this data consumer. They have an information need, but they have no knowledge or skills when it comes to BI tooling, business intelligence tooling. They usually open reports, they click on them, they can open report, they know where to find the reports. And if they have them open, they can maybe filter a little bit and drill down a little bit by exploding certain dimensions like the product dimension or the geography dimension. They might be able on a report to start on a global level and then go to a regional level, like Americas, Europe, Asia, etc., and drill down further to the countries. But that's about it. And they don't want more. That's for them. That's sufficient. Another user type we distinguish a lot is the data analyst. That's a person who performs their own analysis and creates reports on prepared data sets, data marts that I just mentioned. That requires that the data is already prepared. So these people, they really need these data marts, these cubes that I showed you a few moments ago, because they use these cubes to report on and play with. And also they are capable of building their own reports. So when you give them one report, they will be able, based on that same data set that is given to them, to build additional reports. So within the data set given. So they are a little bit more data savvy. So typically these people should be able to use Power BI and build their own reports. And then there's the business data engineer. And that's somebody with a strong affinity for data processing. And they are very knowledgeable when technology is concerned. So they might be able to understand R or Python or even DAX in Power BI and build complex queries and apply advanced functions to build their own even data flow. So if you give them the data mart, they might say, no, that's not what I want. Let me dive into the data myself. Give me the data warehouse. Give me the data lake. Give me access to the data lake. I want to play with the data because I have an idea and I want to see if I can come up with new insights. And the data marts that are out there now that you give to the data analyst and the data consumer, they are not sufficient for me. They are too limited. I need more. So that's what typically a business data engineer does. So here again, I wrap it up. So this is already what I mentioned when it comes to the data consumer, what they can do. It's very limited. What I didn't mention is that they could do some bookmarking as well in the report, and they know how to distribute and share reports, for instance, in PowerPoint, Mail, Excel, but that's about it. And usually they look at an architecture like this. This is what they need to know. This is based on Power BI. I'll give you an example. And what they need to understand is that you can have Power BI reports and that certain visuals on the report can be combined in what we call a dashboard. And that's all they need to know. You don't have to bother them with how a data warehouse architecture looks like. I tell you this because there are a lot of organizations that I work for, and when I come there, typically these people, they are annoyed, but also confused, because the IT people sometimes want to explain in very much detail how data ends up in information and what's being done to achieve that. And by doing that, you confuse them because they no longer understand what's really relevant to them when it comes to reporting. So I always say, stick to this. If they use Power BI, and tell them that Power BI distinguishes reports and dashboards and what's the difference between the two and what it means to them, and that's sufficient. Oh, by the way, if you receive my slides, you will get a copy of my slides. Sometimes I put an eye on the screen here, see handout. If you then zoom in, there are some handout notes below that you can read for more detail, for more explanation. The data analyst is more data savvy. So again, in an example where Power BI is concerned, they know how to create reports based on available data sets. They have some idea of the do's and don'ts of reporting, so how to build a nice report. You may have heard of a person called Stephen Few. He wrote a very good book on Show Me the Numbers. It's something I can really advise to read if you don't know it already, because it tells you exactly if you build visualizations, what to do and what not to do. Because it's not about the visualization, it's about what you want to share, what you want the visualization to display. So people quickly, if they look at it, they don't lose time understanding what the visual is trying to explain or trying to tell them. This person wrote a book about it, even what colors to use, what kind of graphs to use, and what kind of situation. It's really, really interesting. Stephen Few, Few. Well, like I said, the data analysts should be able also to connect to the data mart themselves, get the data in, schedule refresh, build in row level security, of course, build visuals, basics of DAX, which is a programming language in Power BI, how you can derive new columns, how you can add calculations, similar to Excel. So if somebody is very home to Excel and knows exactly how to, and is quite experienced when Excel is concerned, then probably they're a good candidate to become a data analyst and also do this with Power BI. And typically what you want them to know is that apart from the Power BI architecture that I show here, but it could also be ClickTech, Tableau, or what have you, that doesn't matter. You also want them to understand that somewhere in the data warehouse or in the data lake, there are data marts, data sets that are there to be used so that they can connect to them and start building their reports. They don't need to know more architectural layers. Typically, when it comes to the data consumer and the data analyst, an in-house trainings of a couple of hours can help to bring these people up to speed and know how to work with new technology. That's different when you talk about the business data engineer, because this is a real education. If you want to implement on the business side this role, you want people that have SQL knowledge, that know about data modeling. Like I said before, when we build architectures, we distinguish different layers in the architecture. And in each layer, sometimes we use different data modeling paradigms. I don't know if you heard about third normal form, 4, 5, 6 normal form, from COT and date. It was invented in the 60s, and based on that knowledge, companies like Oracle and Microsoft and Sybase could build database engines. But there's also something we call star and snowflake modeling. It's a different modeling paradigm, which is more leaning towards the consumption of the data, where you need like more third normal form or data vault or even anchor modeling kind of data modeling paradigms if you want to store large amounts of data. Because we have a conflict in data platforms that getting the data in and storing it requires another data modeling paradigm than using it for your reporting. So there's always a transition, there's always a conversion phase in your architecture. They need to understand how a data model works, what entities are attributes, keys, and relationship, what ETL is of ELT, because that's what we do. That's the processes we build, the extraction of data, transformation, and then the loading of the data in the architecture. They need to be capable to use tools like Databricks, R, Python, and I'm going to explain the data information delivery paradigm in a sec. And if you, 99% of my customers, they use Microsoft Azure, so you have to have some basic knowledge of the architecture of Azure, but it could also be Amazon, AWS, or Google Cloud, or what's out there? Coursera no, it's not Coursera. No, I forgot the name. There are many vendors out there that package all the software and all the technologies that you need to build a data platform. And it's huge. You have like hundreds, maybe thousands of tools out there. You don't need them. You only need a small subset of them. But when you use them, you have to know how to combine them. So here is again an architecture. From left to right, source systems, data warehouse, data lake, and then on the right hand side, the reporting. It's just another visualization of the same thing. But this is what the business data engineer needs to understand. So they are typically the people that say, the data mart is not sufficient. Let me dive into the other layers, like the history layer or the integration layer, or even the staging layer where the source data comes in. And in some cases, if the data is simply not there, they connect to the data wherever it is using API technology. but that's what they are allowed to do, because we need them for innovation, for coming up with new insights. And that's where the information data delivery paradigm becomes important, and why this person is so important. So here you find the information delivery and the data delivery. It's as if they are different layers in the architecture, but that's not the case. This is more about ways of working. It's a governance, and I will show you. If you look at this graph here, and it's exactly what I've experienced as a young consultant. When a client asked us to build a data platform, we typically always worked in a waterfall approach. That's one thing. So the client always says, when are you going to start and when do you finish and how much will it cost? Simply denying the fact that every time and again we were working with new software, and there were lots and lots of complexities, not only technological complexities, but also challenges in the business. The client themselves needed to organize themselves in order to be able to have a good architecture built. And that was very frustrating because we never reached goals in time and within budget. That's my history, which is very sad, of course. And that's why always people complain about IT. Now, building a data platform is as complex as building a source system, if you ask me. And I was very happy to see that in the 90s, more and more people discovered that we needed to change our way of working. That's what I'll try to explain. If you look at quadrant number 1 and number 2 here in the top, where it says facts and truth context, what it actually wants to say is this, that in quadrant number 1, you look at your data supply, you look at your sources, and that's where the data comes from. So it's like it's source driven, but it's still raw data. And yes, what we do when we build a data platform, we simply pick up the data and we store it. We can do that. That's not complex. Even the data lake made it even more simple, because you can just dump it in there. And when a data lake is concerned, sometimes you don't even have to bother about data models at all. But that's easy, that's convenient. But then if you want to move to the quadrant number 2, truth context, you have to build these layers that I mentioned, like the history layer, the data integration layer, the data marts. You need a very strong business. You need a business person that's very knowledgeable and knows what he or she needs, what the company needs in terms of reporting and analytics. And that's in many cases where things also go wrong, because people sometimes have a very bad idea of the data that's coming in, and also the data quality that I will touch on. So that's where the struggle starts. And that's why it takes so long. So when building a data warehouse in these 2 quadrants, because that's actually what they want to say, you get this iteration of going back and forth. You build your data flow, you build all these layers, you come up with your insights, and then they are not good enough. There are new questions, and then you go back again. And that can take forever. And that's why we encountered situations where you could work for months, half a year, having the business wait and wait and wait, and no value coming out, spending a lot of money and getting very, very frustrated. However, the good news of this approach is that whatever is being built, it's of high quality. It's tested. There is a team working on it. So there are test paradigms in place. So everything that flows there, even if the processes are working, and if all the data flows, the ETL processes, as we call them, when they are in place, and when they are good, then you can rely on them. So we also would refer to that as quality over speed. But when it comes to getting value out of data quickly, that doesn't really work. So that's when quadrants 3 and 4 come in place. That's where we said, now let me first mention this. Because we were spending so much time on quadrant 1 and 2, what automatically happens, what the business automatically does, because they can't wait, they start to build their own shadow IT. they start to load the same source data in their own environments, whatever they have, MS Access, Excel, R, Python, whatever fits you as a business user, you use it, and you start to build your own technical solutions. And initially you might feel very successful and very happy because you have the insights you need, and you no longer have to wait for these IT people because they take forever. However, when your solution is, let's call it, ready, comes a moment in time where you think, oh, it has become too complex for me. I don't know exactly what I built. I didn't really document it. And then maybe I should go to IT and ask them to support it. And what they say is, no, no, no. You're not the only one. But we have 10 more people that build their own solutions. And we're not going to support you. You should not have done that. You should have waited for the data warehouse, quadrant 1 and 2, to be ready. So we are not going to help you. So again, the business is frustrated again. This seems as if there is a discrepancy there, that these two worlds cannot coexist. But that's not the case. We truly believe that even quadrant 3 and 4 are very important. And that is where this role that I just mentioned, the business data engineer, comes in. Because this person should be allowed to build what we then preferably call a prototype by using whatever tool he or she likes and is knowledgeable in, to speed up also the process of determining what kind of reporting and analytics the company needs. Because, like I said, in the top layer, we sometimes have to wait very, very long for the business to come to terms of the report definition. Meanwhile, IT is waiting, or maybe building stuff that need to be demolished later and rebuilt again. Why not stop that process there and then first ask the business data engineer to build his or her own prototype, and when that's ready, hand it over to the IT people so they then can look at it, they can take it apart, and then use it to faster build the data warehouse layers, so that the prototype that was initially built in quadrant 3 and 4 can then be promoted to quadrant 1 and 2 and being implemented in the formal solution that is supported within the whole company and that is reliable, trustworthy, in time, and all these goodies that you need. And then when that's done, the prototype can then be dismantled and people can start using the information coming out of quadrant 2. I made a picture. Wait, let me get this in. Why is the slide not moving? There it is. Okay, yeah. This is actually the same information. Same quadrants, as you can see, from left top, right top. But now I plotted the data warehouse architecture in there. So again, you see the source systems. Number 2 is let's call them the information history layer. The cubes you have there, number 1, the data marts, and then on the right-hand side, the analyst and the consumer, the data consumer. And it says quality above speed, because you want to have reports that can be trusted, because what the business engineer builds on the bottom cannot be trusted because he or she built it, but it was not like properly maybe tested, not 4 eyes looked at it. He used all sorts of technology, he didn't document it. So what we always say, if you implement this way of working, that's fine, that's good, you should do that, because you need this innovation process in your organization. But please make sure that the reports that the business engineer puts on the table, that they have a different format in terms of layout and coloring than the ones that have been built in quadrant 1 and 2, so right top. So what we always say, maybe you should have the reports that are here next to the data analyst and the data consumer in the top. They should have the logo of your company. They should have a certain color. At the bottom, they should have page numbering and things like strictly confidential, what have you. And all this stuff is not on the report built by the business data engineer. So everybody can see, wait a minute, this is a prototype, this is innovation, there could be something wrong. So we should be a little bit more critical. This governance takes away a lot of frustration. I hope it helps you. I don't know if you experience this problem in your organization, but we see it a lot, and it also hampers well, let's call it the chasm that we see between business and IT, and this closes the chasm. This brings the two worlds also together and makes people collaborate, work together, and also better listen to one another and understand one another. This has been a problem for years. Okay, so this is about the information data delivery paradigm in relation to the user types, in relation to the architecture. So here I brought the three things together. Looking at my time. This is the first time I combined this information, and it gave me 2 hours, but I think I don't need the 2 hours. So maybe this is also a moment then to stop and ask if everything, if we're doing well. People have questions or.
I want you to, if you could talk more about speed over quality and quality over speed. Do you mean about speed is by when the like data is needed, or the processes like
It's
development?
it's about first of all, what people need is insights or analytics, and they want that fast. So it's that kind of speed that I talk about. They want to have the insights, and by allowing this business data engineer to use whatever technology he or she likes, and by bypassing all the rules that apply within IT when building a proper solution, like documenting, testing, and all these fancy things, they can come up with a solution in a matter of hours, days, maybe weeks. Whereas if you build a data warehouse, and that's the only thing you do, if you don't allow your business to do anything themselves, we always talk about months to years, even. So that's why we agree to allow the business data engineer to build a solution, although it's not trustworthy, maybe, and maybe not that good quality, but at least he comes with the insights fast.
Actually, I asked this question because I had some experience developing data processing logic that was taking so long to be finished, to completed. And I was always thinking, okay, the performance is not so good, but and that make me get a little bit distracted from the main logic, focusing on two things at the same time, basically having the logic created correctly and at the same time having it perform well. But then I decided that, okay, let me finish one thing at a time, and that allowed me at least to deliver basically the result in discarding how long it takes for the process to complete. And then once the result is completed, then I focused on the speed. But I don't know, maybe that's why I wanted to check. I mean, if that's what you meant, but I think you mean something else as well, is whether you want to develop using the best practices and choose that above speed, or you want to just deliver regardless the quality of the work that you are developing.
Yeah,
it has a lot of aspects.
It has many aspects. Yeah, exactly. Yeah. Okay. Is there anybody else? Yeah.
Yes. I also have a question because it's and I see it also on the slide, self-service BI. I just wanted to ask a question about that because, like, I'm working kind of a centralized data warehousing team, and we're now trying to kind of bridge the gap you mentioned with our, well, not with end users, but more like subject matter experts from like the HR team, for instance. So we're trying to move towards self-service BI, so we enforce them to use our tools to also be able to build certified data sets. But yeah, at the same time, I'm really worried about it, like that it's gonna become too technical for them to really adhere to our process. I'm really doubting, like, okay, should we actually go on this avenue? Like, is it like, will it bring some fruits, or is it just going to be a setup for disaster?
Yeah, it's a good question. Of course, they should be heavily involved in telling what they can do or what education you need. In many cases, they need education as well before they can really start doing this. To give you an example, my latest customer was a large coffee blender in the Netherlands, where I worked for the logistics department worldwide. And they distinguished already some data analysts, but still these people needed like Power BI training to get the most out of Power BI. But well, they succeeded very well in boosting the number of data analysts that started to build their own reports instead of having IT to do that. So there was definitely a benefit there, but you need to hold their hands, yeah, and it takes time. It's like an organizational change. So that's one part of the story. Business data engineer, that's a different story because that's a different person, and there don't exist that many in organizations nowadays. But if you have them, you can assume they are already data savvy, so you can really trust them with more complex technologies to build all kinds of solutions if you want, with even technology that are not really standard, because I'm absolutely against limiting the tools to give to the people in the organization. The data analyst, yes, if Power BI is your standard for standard reporting, then it makes sense to have them build their own reports and help you build reports in Power BI. But don't limit the business data engineer. If the data engineer is very knowledgeable in R, let them then build their reports in R, because it's about the speed that you can have new insights. That's more important than the prototype they come up with, because later on you can then convert it to Power BI. That's the whole idea. So I don't know what's applicable in your organization, because you were trying to get more data analysts, or?
Well, they are already doing the Power BI part, but now we also want them to build their own logic in SQL. So take it one step further. Whereas they would prefer to do it in Power BI data flow. So we're kind of deciding a bit, okay, should we allow them to use Power BI data flow, or should they adhere to our standards with also testing and CI/CD and all that? So I think that's a bit the difference that you explained between having the quality of a certified data set, or just sticking to prototypes. But then again, the central team at some point has to convert it to a certified set. So then the dependency on the central team remains, and the speed is still low, I would say.
Yeah. Yeah, if I understand you well, you say the data flow tool in Power BI, it's very powerful, I noticed. But again, you have the risk when people use it, that 3 people build 3 different solutions, and that's not what you want. In the end, when it's about formal reporting, like organization-wide reporting, you want to have it built technically the same. So somehow it has to go back to IT, has to be re-examined and rebuilt. And of course, it then will take some extra time of IT. The good news, of course, is that having the data analyst first also build a little bit of a prototype in Power BI helps already in clarifying the information requirement. That's maybe the benefit you have.
Yeah. All right, thanks.
Okay.
I think Yemin had a question.
Yes. Actually, I used to build a mail system, an integrated mail system, from the data collection part until dashboarding and reporting the data collection. I'm trying to always to automate the data collection process, but I always facing some trouble with prediction of what can be cleaned more in this data, and automate the cleaning process. in the data model. So I used to get data from Kobo, for example, and pull it in the Power Query, and then I do the steps for data cleaning, and then publish it to on Power BI for dashboarding, and then I publish it for the managers to see the full report. But I always struggling with the data cleansing process. So what do you suggest for this?
Yeah, that's a good question, because this touches on a problem with data quality. Because in the end, you don't want to clean data. It should not be necessary, but I know it's a fact of our life. Now, first of all, let me tell you this. When we build data platforms for organizations, we prefer not to clean the data. We say garbage in, garbage out. Because by doing so, you confront the business with the shit they create. Because that's what it is. Data is bad, but I'll touch on that later on. Data is bad because they didn't implement the proper data governance, proper data management in that sense, which is a business responsibility. And if that's not in place, you will clean the data forever and ever and ever. It will never stop. It's like an open tap, a running tap. In Holland, we have an expression, dweilen met de kraan open, mopping with the tap open. That's not what you want. So one approach is just let the data come in as it is, and also demonstrate the consequences of it. But I know that's not always working, because sometimes the people that you use it for, the data, they are not responsible for the data coming in, for the data sources or the data quality. So there's a mismatch there. And that's about governance again. It's about responsibility. It's about compassion. Me doing my job better, so you benefit from better data, and me feeling responsible for your quality of insights. That's the only answer I can give, to be honest, because yeah, like I said, cleaning is I know we do it occasionally, and even in the past, yeah, we always did it. But it causes your technology also to become more and more complex, because you have to have a solution. You have to implement a technical solution for every kind of error that can occur, which makes your code complex also. Yes, please. You wanted to elaborate?
Yes, thank you. Yeah, that's exactly what I'm doing. I always try to make sure that the data collection tools is super perfect, has a super perfect quality. There's no logical issues or something like that. So that in order to not to have the garbage out from the data model. Thank you.
But I tell you, the moment that you leave, and I hope you document everything you build. I hope you do that, and that you explain what's happening where. But I tell you, the moment you leave and somebody else come in, they will not understand. And because it became quite complex because of this, they might be scared to touch your solution, and they might want to start building a new solution to prevent having to dive into your code. That's why we always say, and it relates to data lakes, but also lake houses and data warehouses. We say there is a graveyard of data warehouses out there because of this. Because it became too complex because of all these kind of things. Are there more questions at this stage? Let me see, it's 5 o'clock.
Ramona would like to ask if you could elaborate the difference between data lake and a lake house.
Okay, I'll try to do that once more, because I think I did it maybe a little bit too quickly. It's about definition. A data lake is perceived, but we had a discussion with colleagues a couple of weeks ago, because we wanted to have a shared vision in my company, so we took some time to dive into it. A data lake was sold to the market, or was sold to our community as a solution at some moment in time to be able to deal with not only structured data, but also semi-structured and unstructured data like video, audio, pictures, text, what have you. And the whole idea was you just throw it in. And when I say throw it in, let me take an example. Let's take Microsoft Data Lake Storage, DLS. That is a layer where you can just simply dump in your data, and then somehow part of that data is automatically still transferred to table-like structures, and of course part not, because it's unstructured. And that was sufficient. So what they then said, what the gurus then said, is all you do then is you build on top your own data prep technology solutions, and whatever you need. You can even build data marts if you like, and then you can have your reports again. But what they also said then was, yeah, they didn't bother about all the nice layers that we distinguish in the data warehouse. Like I mentioned, we have a staging layer where we bring in the source data. We have this history layer. We call it also, another name for that is HDA, History Data Archive. But it's a kind of a layer that is modeled to build up history so that no record is overwritten. So we can always trace back what happened. Yeah. Then the next layer was this business data warehouse layer where we integrate the data. So where we bring everything we know about one customer in a 360 view together, or a product or a geography or whatever, what have you. And then on top was the data mart. Somehow in the literature also they said, that's too complex, it takes too long, because part of it, of course, a complaint was it takes too long. Yeah? Having a data lake is easy. You just throw everything in, and then whatever you want, you just dive in with technology that you like, and you build your solution. So what we lost was the goodies of the data warehouse, because the data warehouse was there for a reason. People still need structured information, and they also want to be able to rely on it. They want they want these processes to be of high quality, repeatable, in time, etc., etc. And somehow, when the data lake occurred, as if people said, we don't need that anymore. And that's not okay. That's not true. So that's what, when many companies, they were so frustrated, they buried, like I said, there was a graveyard of data warehouses over there. They buried that data warehouse and they implemented the data lake, and they thought, now we are ready. Now, I visited a lot of these companies over time, and what I noticed was, okay, so now, what's the shape of your data lake? And when I spoke to them, at first, it was just one simple layer. But over time, we noticed that they were building in the data lake the same layers as we distinguished in the data warehouse. Now, let me mention the names again. In the data warehouse, we had these layers. They were called like staging, History Data Archive, HDA, or Source Data Warehouse Layer, SDW, Business Data Warehouse Layer, the data mart. In the data lake, all of a sudden, they had names like bronze, silver, gold, or another example, raw, curated, enriched, and oh my God, raw, landing, enriched, and curated. And for me, looking at that, not only for me, by the way, because I see a lot of articles about it, it's just old wine in new caskets. It's like, if you talk about raw, you could say that that's my staging area, or my source layer in the data warehouse. Landing is my staging area, maybe, or my history data archive. Enriched, that's my business data warehouse layer. Curated, that's my data mart. So we saw the same layers appear in the data lake. And that's when people said, yeah, then what we did is actually we have a new evolution, and that's what they started calling the lake house. So if you read articles about the lake house, you will hear these terms coming up. Is that a little bit more clear to the person who asked?
Yes, that's better. Yeah, thank you.
Okay, all right.
There is also one more question. Can you elaborate with the data lakes and the correlation with the data lake house and realistic additional examples? How about having unstructured data will influence in those examples?
Can you repeat that question?
Can you elaborate with the data lake and the correlation with the lake house and realistic additional examples? How about having unstructured data? Will it influence those examples?
Ooh, the best I can come up with, if I understand the question, is otherwise the person who wrote it maybe should jump in. I believe that no, having a lake house or a data lake with all these layers, which is similar, we are able to combine structured and unstructured data. But in order to be able to do so, that structured data is already structured. That's why it's called structured. But semi-structured or unstructured data needs structuring. That's why you need technology to transform it into something that's usable. Because one video, you cannot use it unless you analyze it and then come up with structured information about the video. But if the moment you have it, you can combine it with the already existing structured data. So now is where these two worlds come together. So when you have your data lake where you store in everything, structured and unstructured, in the end, you can still model this data into the different layers that I just mentioned, and even combine these data, structured and unstructured, to become used in a structured way of reporting. It's exactly the same process. You create unstructured data or data in general. You transform it into information by applying logic to it, whatever that is. Could be vision recognition, image recognition kind of software. But again, when you implement that image recognition, you are looking at raw data, raw structures, but you convert it to something usable. Is that an answer that needed to be given here? I don't know. I just curious.
I think so. Thanks. I think we can, that's all the questions for now. I think we can move on.
Okay, it's 5:10. All right, that's cool. Okay, let's talk a little bit about bad data quality. So we don't need data cleansing anymore, because we really have a problem. As long as I'm in the business, this has been our biggest issue of all time. Although we build beautiful data platforms and data warehouses, and they all work, in so many cases we see so much crap come in on the one hand, and on the other hand we see so much businesses not being able to ask proper questions because they don't even know themselves what kind of data is coming in or what the quality is. This needs to be addressed. And there's a good reason, because bad data can cause serious problems. Like you chase away your customers, you miss opportunities, but you can also have legal challenges. Yeah, reputation damage, but also it can cost you a lot of money, and you can even go bankrupt if you don't organize yourself. And it still amazes me today, when I finalize this chapter, but I mentioned it already up front, that hardly any organization has data governance properly organized and has laid responsibility in the business. That amazes me after 35 years of being in the business. And I hope that that's going to change fast. Because data is a very important asset for almost every organization. And where in the past some organizations were focusing on a certain type of service provisioning or product development, some organizations even found out that they have so much valuable information in their house that they even start selling the data or start using the data to strengthen their business propositions, their business models. But this is typically what every organization does. Like keep record of your operation, planning activities, setting targets. We all talk about dashboards and looking at actual data, but also looking at the budget or the target, and then also appraising people for their performance based on the targets. And of course, we report internally, but also externally, especially when you're a big company. You need to be reliable, even if you're on the stock market. Everybody's looking at you, and everything needs to be spick and span. And I worked for organizations that had really bad data, and somehow they still managed to bring out annual reports. And it's so untrustworthy. I saw companies report stuff without blinking their eyes, while they were not properly organized. So it's a big thing. It's a big it's a big issue. And what many companies don't ask themselves are these simple questions. Like, is the data sound, like complete, accurate, consistent? Is it useful for its intended users? Is the data there on time? Do we understand the data? Is the data dependable or reliable? Is it also being audited? Is the data trustworthy? Can we trust it? Is it objective, or is it safe to use the data? There's hardly any information in organization present that touches these topics when the data is concerned that they work with. I will not elaborate here too deep, but there are typically two dimensions that we look at. Sometimes you have like a product or your service that you deliver, and you want it to be of high quality. Your product quality needs to be good. So you need to have sound information about your product. And here you have the terms again that I just mentioned, like it needs to be properly defined. And when I mean defined is that each attribute that you use in your organization, you need to document it somewhere. What is it? What are we talking about? And sometimes it may be easy when I talk about when you store customer information and you talk about sex. Well, in the past it used to be easy. We had males and females, but look at today. I mean, it has become much more complex. We have all these gender ideologies, and as a company, even if you store something like sex, if you are allowed to do that, by the way, but you need to define what's in there. What does it mean? If you don't only differentiate between male and female, but you have other things that you store for whatever reason, you need to document it. Yeah, and also you need to document when the information needs to be available. Its consistency also in relation to maybe other attributes that you have in your organization, because data depends on other data. Data doesn't stand on its own. One attribute doesn't stand on its own. Now, same goes for process. So on the one hand side, you have your product or your service that you deliver to the market, but you do that through processes. And also the processes you document. Yeah, you want them to be repeatable, continuous in time, conform to defined measurement. All this stuff needs attention. And what I always noticed in the past is that people are really concerned, for instance, about the process flow, but not about what's documented within the process flow, by whom, and what the requirements are in terms of all these aspects that are so important. This slide elaborates a little bit on data dependency, because if you have different departments and people in organizations, you have a blue department, we have a green department, a red department, and we talk about, in this case, a product. We have not only the product, but together with the product comes the data about the product. But a department further down the line depends on what happens in the department before, or what people are doing before. And if the people earlier in the flow are not concerned with data quality, they really harm the departments that follow later on. And this awareness is only available in organizations, very limited. That what I do, how I store data as a responsibility, that it affects other colleagues in the organization maybe 1 or 2 weeks later. I worked for Philips, a good example, and I remember they had they were talking about this product data management environment, because when they are thinking of a new product, it's primarily research doing that. So they have a limited laboratory setup where they are working on new products, and they try to come up with some new technologies that the consumers might want. And when doing that in the research department, they might need 100 attributes to describe what they're doing. But the moment they have a new product, they want to start producing it. It goes to production. So they have to set up a factory, and they have to set up assembly lines. The amount of attributes that they need for this particular product that's going to be developed, it grows enormously. So it can go from 100 attributes to maybe 1,000 attributes. And that's still production. And then it goes to marketing because the product needs to be sold. And after that, when the product is sold, you want to deliver service and guarantees that people can come back and complain about the product. So in the end, you have like 10,000 attributes regarding this particular product. And what you will see is that there's not one person responsible for all the attributes. It's like different departments, different business organizations that take responsibility for part of the product data set. So you have research, you have production, you have marketing, you have service and delivery. Somewhere there's logistics still. It's rather complex. And what I document in the research phase can be very relevant for the marketing department later on, or the production facilities. So that's what I try to demonstrate here. So together with your product, your data needs to be of very, very good quality. And that's in many cases not the case. So if you want to describe what data quality is or why it's so important, well, if you want to do something with data, that's what it says here in the bullets. Without a business content, there's no meeting. Yeah? So if there's no business context in which the data originates, yeah, why is it here? Why is it there? And if it isn't defined, you can't measure it. If it isn't measured, you can't monitor it. And if there are no targets, you can't manage it. And so you can't enhance in that term. Without governance, it's every man or woman for himself, herself. So then everybody's doing something, but they're not really benefiting the company. And this is what's the case. And this is so important to do when data is concerned. Now, let me give you a little bit of an insight in some research we did with a large group of high-tech companies in the Eindhoven, Netherlands area, because we were looking at this and we said, hey, this is a big problem. And we noticed that there are 5 pillars, 5 dimensions when data quality is concerned. And I'll explain them high over a little bit. The first one is MDM processes. MDM stands for master data management, but forget about master data because then people say, yeah, but you're talking only about master data, like the geography or the product or the organization, but I talk about data in all its appearances, even the transaction data that need master data to be able to understand, but also transaction data needs to be of good quality. So, but for convenience sakes, today we still call it MDM as a whole, master data or data management. MDM processes refers to the all the processes that we have in place to make sure that within the organization the right people are working together in doing everything that is required to enhance data quality. So it's about the way in which we organize the data quality process. Another thing is data quality management, left bottom. Data quality management is about the roles in the organization of the people working on a day-to-day basis in getting the data right. I will touch on that because there are some rules like the data owner, the data steward, but I'll come back on that in a couple of slides. And then, of course, we have the governance and the MDM governance. And the MDM governance is about the rules and guidelines that are applicable. So you have your processes like your meetings or your ways of working with the roles I just mentioned, like the roles I just shortly mentioned already. And the governance is about what we agree that we do together and what standards we use to make sure that data quality is benefited. Then we have 2 other pillars. It's called technology and integration. Technology is about eventual tooling that we could use to help us get data quality right. And integration is about rolling it out in the organization. When you're a large company, you might want to start doing this first in a small department. And when you're successful in a department, you could escalate it to a divisional level, or maybe in the end to a whole company level. Philips used to have like 6 or 7 divisions, and we have been implementing this in one division, in one business department, consumer electronics. I remember in the TV and radio section, But once we were successful and everybody understood what was required, we could then extend it to the rest of the organization slowly, like other divisions, like lighting or components, because that takes time. And by the way, I can tell you one thing: if people want to enhance data quality, then the first thing they say is, "Oh, let's buy a tool." That's the last thing you should do. Excel is fine. If you want to enhance your data quality, and you have like thousands and thousands of attributes, there's nothing wrong with downloading them into Excel, then assigning responsibilities to it, and find out who's responsible for what groups of data sets, ask them to come up with definitions, ask them to come up with the stuff I already mentioned, like what are the typical values we allow to be entered in this attribute. So what are the boundaries? What's the lower limit, the upper limit, or what list of values are allowed to be entered into this attribute? That's the basic stuff that we need to do, and somehow we don't do that. But if you come up with that already and you use Excel, for goodness sake, it's okay, because at least you have something to monitor your progress and to be able to focus departments, people on the same goals that you have in getting your data right. Now, what we found out is this, in this research, when you look at many organizations, they have, in general, none of these pillars properly implemented, just sometimes very quite limited. They don't have a master data management process in place. They don't have roles. They didn't assign certain roles to people in the organization already and make them responsible for data quality. And there was no set of guidelines like the governance agreed on to be implemented. But what we noticed, and what was also a best practice within some of the companies that did better, is they first spend more time on getting the processes right, getting the roles assigned, like data quality management roles, and the governance assigned, before buying technology to help automate and roll it out in the organization, and before rolling it out to other parts of the organization, so the integration. And what we also noticed when we look deeper is that they even spend more time in getting the processes right, like think of the boards that you need to set up, and the meetings, the agenda of the meetings that you need. They spend more time in defining that, even before embracing technology and rolling it out to the rest of the organization. But the moment you have that in place, your processes, your governance, and your data quality management, then is the time to look for technology. And that is the time to roll it out to the rest of the organization. And to give you an example, because one of the questions, of course, raises, what kind of technology should we look at? Now, there are companies like Informatica. They used to deliver an ETL tool in the past, Power Center, but they became very knowledgeable about this kind of support they provide. Informatica is a company that sells technology now to help you set up master data management. Another example is oh my, what's the name again? It'll come back in a sec, I think. When I remember, I'll tell you. But it's typical tooling that's rolled out in a kind of Wikipedia format, which allows people in the business to log in and look at the data the data attributes that are being used within the organization, and allow them to add meaningful definitions and come up with the values that can be that should be able to be stored in these attributes and whatnot. Yeah? But what you see when you talk about technology, sometimes you see technology that's very business focused. So it's more like text oriented. So explaining more what we look at. What we as IT people sometimes want is technology that goes one step deeper, because sometimes you have an attribute that is like a calculation. It's derived from other data, for instance. We call it business logic. And in the ideal situation would be, my holy grail is that you have one environment where people can document the data quality aspects of all the attributes that exist in the organization, and also enter formulas. To give you an example, let's say The sales value is price times quantity. Yeah, it's a simple one. We have a price, you have a quantity. If you multiply the two, you have your sales value. We have sold so many in revenue. So revenue, that's your revenue definition. How wonderful would it be if you can type it in as a business owner, what the definition of revenue is. And we IT people, when we build the data warehouse, we use that calculation to implement it in the data flow. If you change your definition, that automatically, without an IT person having to change the business logic, it's automatically taken from that environment and being used in the data flow from tomorrow onwards. I haven't seen that yet, unfortunately. It's my dream that at some stage, at some moment in time, hopefully, we can see that happen, because that would mean that everything comes together, business and IT, everybody taking responsibility for the data quality. So, like I said, some explanation here. Governance is the structure and decisions that you use to organize the business in order to achieve the goals. The management is then the decisions you make. The operations are the actions you take to achieve the targets, and the architecture is how you do it. The structures and guidelines you define to ensure coordinated implementation. So there needs to be a business intent. You set some targets. Your policies have to be in place. Your standards, your controls have to be in place. You need to have some organization structures. As you can see it in the picture on the left-hand side. So you define your processes, you have your methods and your standards that you define, your metrics, and of course your controls to check if the metrics are being met, and if the data as it exists in the organization still fits the quality that we define. And like I said before, you need roles to support that. So you have like I'm happy if two roles exist, like the data owner and the data steward. Here you have three examples, like the data custodian is even in place here. That's the formal owner of the data produced in the business process domain. Sometimes the data custodian is somebody high-end in the organization, like a director, like a marketing director or a financial director. And then you need a data owner who is responsible more on a day-to-day business to manage the data quality, but more in terms of if issues arise. And they usually rely on people like these data stewards who are more technically organized, who execute on a daily basis on behalf of the custodian and the owner the data quality. So they can, for instance, decide to do mass updates. If something is really seriously wrong, they can decide to go to the systems and make sure the data is correct and fix the data there. Or, but that's also part of the data owner's responsibility, decide to change the business processes. So if data is structurally wrong, you might want to go back and change your business process and say, hey, we're doing something wrong here. For some reason, a source system or a certain group of people is not working properly and they're feeding in wrong data on a continuous basis. We're going to train these people. So tomorrow they do it better. So the data becomes better, because that's what you want. You want to make sure that data quality is good from the beginning. And these people are responsible of doing that. It's their responsibility, apart from what other business responsibility they might have. So it's a role. Yeah, it's not a function, it's a role. And everybody can have that role in an organization. Well, this is a throw out. So do not think in terms of data quality as a means in itself, but as a means to an end. So the data quality should be in place because your business then benefits of it. Data quality is the result you're after. Make sure it's part of what is measured and managed. Oh yeah, and it's not a project, it's not a program, but it's part of your standing organization. It's part of your day-to-day activities. It's always there. It will never go away. Even if you managed to enhance the data quality of your organization, you will see that in the future new problems arise, and then you still need to revisit all of your processes, your governance, and your roles, and your systems to make sure that you fix a newly problem that just newly occurred in your organization. By the way, it's not an IT activity, it's a business activity, it's a business responsibility. And this is maybe one of the reasons why it's done so badly, because many business people I spoke to, they are not waiting for responsibilities and activities related to data quality. They are busy, they say, with what they are doing, be it marketing, product development, or logistics, or whatever it is. They are not waiting for another responsibility when data quality is concerned. But it should. You should. Force is a very bad word, but I'm very serious about this. I saw many business people getting away with it, and it's not good. It's not good. Data is owned by the business, and its quality is primarily a responsibility of business people. And of course, this data quality causes frustration, so it automatically leads to blaming. Well, that's not, of course, not good. It's a collaborative process. Everybody creates data, everybody enriches data, and everybody needs that data. So we better team up and work together because it's a collective responsibility. Okay, this is good because I don't need much time for data privacy protection. Are there questions regarding data quality?
I don't see any questions in the chat.
Okay. Is there anybody who organized it, who has implemented data quality in their organization and is very happy about it? And share this with us. Or the other way around, is there anybody here who sees that this is a real problem in their organization? Maybe this is good news. Okay, then let me finalize with
Hannah says that in the chat that it's a huge problem for them.
Yeah. Okay, thank you. Yeah. Okay, some words on data privacy protection, because this is, of course, very important and became very important over the years. Speaking on behalf of the Netherlands, in my country, we now see some very serious issues of the fact that this was not there. People have maybe heard about, in Dutch, what was called the zorgtoeslagaffaire and the kindertoeslagaffaire, which is about our tax department, the tax government, who really destroyed about, I don't know how many homes because of the fact that even our tax authority did not adhere to the data privacy protection and started profiling people based on their ethnicity, even without documenting it. And they shared lists of people that were considered fraudulent but were not fraudulent. But they thought they saw some aspects regarding these people that they didn't trust. So it ended up with many families that were abandoned by the government and could not seek help anywhere, but were not trusted anymore, resulting in tremendous, very terrible financial situations, and even some situations where children were taken away from these families. So this is, in the Netherlands, this is now a very hot topic. And even our government fell on this topic. So I think it's good to touch on it. But also organizations have to deal with this and have a responsibility to take. Organizing data privacy is crucial, like it says, to ensure that sensitive information is handled appropriately and in compliance. To be honest, a long time ago, I thought, what the heck? Because it was a burden when building data platforms and also when providing data and information to business users. All of a sudden, we were not allowed to give that information anymore. They needed privacy impact assessments documents. They needed to explain what they were going to do with the data. But to be honest, when I learned about the problems we had in the Netherlands with what our government was doing, I was thinking, oh no, this is a very good development. We really need this. And now you hear more cases in the market. So what does it mean to you? What do you need to do? Now, if you go on the internet and you look this up, it's a huge topic. I tried to come up with some of the more, I think, high level, more important aspects, because you can elaborate on this for hours, and we don't have that now anymore. But of course, number one is understand the applicable regulations. There are different levels of privacy protection now that exist in the world. in the EU, in the US. I think even that the EU is getting more and more strict. Even Germany is, I think, is the strictest of them all. They're all struggling still. They're still thinking and evolving. That's good. I think I even saw an example of Canada when it comes to data science and analytics. Of course, people nowadays want to use data and do very exciting stuff with that by using machine learning technologies and stuff. But I noticed that I think it was Canada. Canada is the first government to say that we are not using these models, these data science models, if we cannot explain them and document them, so everybody can understand what they're doing. If they are black boxes, they are not allowed to be used in a government setting. I don't know if that's a good idea, but it feels good somehow. If you can't explain it, you're not allowed to use it. Now, I'm not a data scientist, but I try to understand things like neural networks and stuff. And what I understand of it is it's a pretty black box. So I don't know if it automatically means that you cannot use neural networks in a governmental setting or in a setting where people are affected. Because of course there are other settings where when people are not affected, it's not a problem. But it made me think. I follow this also on my university. So when there's a workshop on this topic, I attend it because I think it's very interesting. In an organization, it's good to appoint a data protection officer. And again, this could be a role, of course. At least make somebody or a group of people responsible for overseeing if your data protection strategy is followed, so you stay compliant. Well, although this is tedious, when I spoke about data quality, it's applicable here as well, because examining all your data is huge, but you should. And I think when you're working, this should be part also of the governance, of the data governance in general, and the board of people that are responsible. They should have this in their basket as well. On a continuous basis, they should conduct data inventory and data audits. Who's using what? Are the privacy impact assessments in place? What is the sensitive data that we have? Make sure that we process it and store it differently. It's very important. Together with that comes the classification of the data. So categorize your data based on sensitivity. It helps you because when you build also data platforms, then you can more easily distinguish what data needs to be treated differently and maybe be protected accordingly. Think in terms of anonymization, pseudonymization, this kind of things. So document and implement protection policies and share them with the organization. Make sure that everybody is aware of this throughout your whole organization. When collecting data, make sure that you obtain consent from the start. When you work with customers or clients or patients or whatever, ask them for their explicit consent. And I know it's tedious and again boring, and sometimes from a research perspective it can be harmful, because if you know that if you have to ask for consent, it could be that the amount of data that you can use for your research decreases, but then that's the case. But if you don't do it, you can be in serious problem. Implement security measures, the things I just mentioned already, like encryption, access control, regular security audits, etc. Employee training. I've seen some good examples of employee training already. I consider myself quite a knowledgeable IT person, but when I started working for one of the companies lately, I had to go through one of these trainings, and all they did was they showed me some examples of some emails. They asked me, is this email legit or is it fraudulent? And also I made some mistakes, and I was like, oh, I learned some new tricks that the scammers out there are because they're also evolving, and they get better every day, and we have to weapon ourselves against them. Yeah, today it's quite common to share data with third parties. We collaborate in a complex world, and also they should follow similar data protection standards. So you have to have contracts in place, you have to sign off data processing agreements, etc., that outline responsibilities. And when something goes wrong in the end, this is also a good one. Like you need a backup for your database, but you need a data breach response plan. If there is a data breach, you have to have a plan that you can kick off immediately, like a step plan from step 1 to step 2 to step 3, to limit the harm that could be done to your organization or to society. And everything should be in there, like notifying affected individuals, but also inform authorities. In the Netherlands, we have an organization that if there's a data breach, you have to tell them. You have to notify them, and they then also help you, but also look at the situation and can maybe advise in steps you need to take. So as I throw out, remember that it's a shared responsibility, and everybody is involved: leadership, legal teams, IT, HR, and everybody needs to work together to get a good data privacy protection framework. This is what I wanted to share with you on data privacy. At this stage, I want to thank you for your time. I'm honored to be able to share some thoughts on information management and these pillars with you. Like I said, from architecture to different user roles, the information data delivery paradigm, ending with data quality and data privacy aspects, as was asked by the ABW team. They wanted to have me elaborate on these aspects. If you have any questions, please go ahead. Are there topics you missed, maybe for another time? I'm very curious, but thank you so far for.
Thank you, Pieter. If there's any questions, you guys can put them in the chat or go ahead and raise your hands, and we'll take any questions that you guys have now.
And from tomorrow onwards, Kate, I will share my slides. And like I said, in the comments, you will find more information, quite elaborate sometimes, to explain what's shown on the slide.
Wonderful.
And I'll put it in Slack, I guess. There's somewhere I have to upload it. No, not Slack. It was GitHub.
GitHub, yeah. Martine, there's a question?
Yeah, well, it's actually kind of the last topic you mentioned about the data protection was kind of triggering me about the case that or the project that we're going to do for this fellowship. Mm-hmm. So it got me thinking, like, okay, so if I want to use the data from the donors to our organization to do some demographics analysis on that, like, what kind of consent should we have asked to these people, like, or just by, I don't know, like being a donor of the organization, they automatically consent? How does that work on a more concrete level?
Okay. If I don't know about the data, but if the donors collected data themselves and collected data of individuals, they should have asked consent. And part of the consent is also about asking the individuals whether they allow, for instance, that research is executed based on this data by them or their partners, and you could be a partner. And in that case, there should be a joint agreement between you and the donor, where the donor explicitly allows you to do the research for them based on the consent that was given to them. This whole flow needs to be transparent, and if there is an organization that's going to control you, or it's going to do it's going to visit the donor, for instance, or you, then you need to be able to show this documentation, all this approval, and all these contracts.
Okay, well, I'm not so sure how that's all arranged in our organization. So yeah, there can be quite some hurdles, I guess.
Now, these donors, are they
like they're donating money to our NGO, to MSF.
on money, but
Yeah.
they're not donating the data. I mean, are you
No.
using data?
Like it's about like money. Like we want to get insight in demographics of people who give money. So like these kind of things.
Okay, yeah. You have to be careful, because if you use their data about their person and for another purpose than the donation they gave, then you could be in trouble. Yeah.
Thanks.
It's called goal binding.
Yeah, I'll look into it a bit more. Thanks.
Okay.
Are there any other questions?
Let me switch on my video.
All right. I think that is it from everyone. Please, everyone, remember to fill in the survey for both today's sessions, both of the today's sessions that we had. And on behalf of all the fellows in ABW, Peter, I'd like to thank you so much for this great session. And I hope everyone has a wonderful rest of the day.